Hi guys, and welcome to your video for lesson 2.1.3, which is called What is the Relationship? So we are basically talking about more angles formed by transversals. So the lesson objective for today is that you will continue to apply your knowledge of corresponding angles and will develop theorems about alternate interior and same side interior angles. Students will also learn that when a light beam reflects off of a mirror, the angle of the light hitting the mirror equals the angle of the light leaving the mirror. So you guys will experiment with that all later in this lesson. But for today, what I want to do is I want to go over some vocab and then just to refresh our memory so that way we are constantly talking about it. It's constantly in our brains. Then I want to go over question 2-24. And then some review problems for us. So the very first thing I want to do is I want to talk about some vocab. So if we're looking at this, we can obviously tell this is a right triangle. And if we cut this right triangle by two angles, we know that those angles have to be complementary. Which means that they sum to 180, or sum to 90, sorry. So just a quick refresher, complementary means sum to 90, which means these two angles right here sum to 180, which means they're supplementary. Alrighty, so that's kind of what we covered in the first section. Then yesterday during class, so Tuesday's class, we learned all about a transversal, which is this guy. And how a transversal is a line that cuts two parallel lines. It intersects two parallel lines. So we talked about corresponding angles. So this guy and this guy are corresponding angles. But we also talked how this blue angle is equal to this blue angle and how this blue angle is equal to that blue angle. So we covered all of that, and we talked about all of that in our class on Tuesday. So those angles, all those blue angles, would be considered congruent. So congruent means the same. Another thing that you guys are going to talk about today is this idea of alternate interior angles. So they have to be angles on the inside, and they are alternating. So this angle and this angle are alternate interior angles, and they are the same. So if you ever hear anything about alternate interior angles, that means that they are the same. And then we have one more definition I want to cover, which is same side interior. So again, interior meaning it is inside of our figure, so down in here, and they are same side. So it would be this angle with this angle. So same side interior. And those ones sum to 180. So a lot of different definitions, a lot of different things to remember, a lot of stuff being thrown at you. So the more we talk about it, the better off we're going to be. And so that's why I know you guys are probably sick of hearing me talk about corresponding angles and the transversal and summing to 180 and all of these fun stuff. But it's something we need to talk about because there's going to be a lot more definitions. So we need to make sure that we continue to address these and we continue to remember what they are and what's going on. So there are definitions. Alrighty, let's jump into question 24. Okay, so whenever one geometric figure can be translated, rotated, or reflected, so that all has to do with our chapter 1, so that it lies on top of another, the figure must have the same shape and size. When this is possible, the figure is said to be congruent, and that symbol is used to represent it. So that guy right there is used to represent congruent. So review the angle relationships you have studied so far. Which types of angle measures are congruent? So if we draw this guy right here, we can talk about our vertical angles being congruent. So we got vertical angles. We also have corresponding angles. So if you see something like this, that guy is equal to that guy, so corresponding. And that's pretty much all we've covered, even though we went over more stuff. In that vocab section, that's all we know so far. So this was all of section 1, this was all of section 2, so we're about to dive into section 3. Okay, so angles are not the only type of figure that can be congruent. For example, sides of a figure can be congruent to other sides. Also, a complex shape, such as a trapezoid, can be congruent to another if there is a sequence of rigid transformations that carry it onto the other. Consider an isosceles triangle like the one shown below. Because of the reflection symmetry, which part must be congruent? So you guys have actually done this, you guys have talked about this, you guys did this in your exit ticket, and the correct answers should be that guy and that guy. Those angles are congruent because if you take that triangle, let's say you have a real life isosceles triangle in front of you and you fold it in half, angle A is going to lie perfectly on top of angle C. And if it lies perfectly on top of it, that means that they have to be equal. Alrighty, so that's all that question's asking. So just a quick little review. I know you guys did that problem already, but I just wanted to talk about that so we could clear that out of the way and you guys could jump right into question 25 today. Before we move on, there's one thing I want to talk about first, which is notation. So if I wanted to write that angle A and angle C are congruent, we want to move away from just that circle drawing or our little line drawing right here, anything like that. We actually want to start making mathematical statements because this is going to make our life easy if we are good at this when we come to proofs. So what I want to do is I want to write the measure of angle BAC. So angle measure of BAC is congruent. So there's that little congruent sign again. The measure of angle BCA. So that's how you'd actually write that answer to question B on your paper. Alrighty, so now we'll go into some review questions. So these are questions that you would see on your homework, but we're just going to continue to review them through the video. So that way on your exit ticket, you guys have more of the relevant information you guys need. So if we're looking at question 2-31, it says a set of equations below is an example of a system of equations. So if you don't remember what a system of equation is, go back and read your math notes. And you learn how to, in that math notes, it talks about substitution. So you're substituting in a problem to solve the question. So the first one says graph the system on graph paper, then write its solution. So we're going to start with that. So we have this on our graph paper. I am going to draw my x and y axis. And for this one, my y-intercept is +1, so it's going to be right there. And I am going down 1 over 1. So it's -1 over 1. So down 1 over 1, down 1 over 1, so on and so forth, because it's got a negative slope. And then I'm just going to connect that line. Then we have 2x plus 7. So my y-intercept for that is going to be 7. So 1, 2, 3, 4, 5, 6, 7. And I'm going to be going up 2 over 1 because it's rise over run. So I'm rising up 2, I'm running over 1. I'm rising down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. And we actually see where the lines intersect. which is what we wanted right here at that point. So we are at -2, 3. So that should be our answer. So x should equal -2 and y should equal 3 when we go back and actually do the problem. So I'm going to jump back over here to the review problem. And what we are going to do is substitution. So it says, doing an algebraic method of your choice, did the solutions match your result from part A? So if I have something equals y up here and I have something equals y down here, that means they're both equal to y, obviously. So if they're both equal to y, that means that they're both equal to each other. So what I'm going to do is I'm going to take this equation and I'm going to replace it with y. So I'm going to have -x plus 1 equals 2x plus 7. You could have done it the opposite way too. You could have taken 2x plus 7 and substituted it in for y. So I am going to bring all my x's to one side, and those cancel, and my numbers to the other side. So that cancels. So I am left with -6 equals 3x. So I'm going to divide by 3, and my x is going to get me -2. So that one checks out. Now all we have to do is go back to our original equation and see if it's going to still work. So I don't really like negatives, so I'm going to plug it into this one. You guys can plug it into whichever one you want to, but I like plugging it back into 2, -2 plus 7. So I have 2 times -2 is -4 plus 7 means that y is equal to 3. So if x equals -2, y equals 3. Hey, that checks out. Moving on. Alrighty. On graph paper, draw a line segment AB that A is at 6,2 and B is at 3,5. So I'm going to go back over to my graph paper. I'm going to erase all this. Make a new coordinate grid. And then plot those points. So I had 6,2 and 3,5. So I'm going to go over 1, 2, 3, 4, 5, 6, and up 2. And then 1, 2, 3, 1, 2, 3, 4, 5. Alrighty. So that's a line segment, so we can go ahead and connect those. So reflect AB across the line x equals 3. So x equals 3 is going to be at 1, 2, 3. So that's the line I'm reflecting it over. So I know that this point's going to stay the same because it's on that line. It's not going nowhere. And then I'm going to move this point 3 lines over. And then it says connect A. So this guy was A, and this is A delta, and this is B, which is also B delta. I'm going to connect A with delta A. And then it says what shape is created by the reflection. And we should all be saying that this side is equal to this side. So it is an isosceles triangle. Then it says what polygon is created when AB is reflected across the line y equals -x plus 6. So I'm going to write that down. Y equals -x plus 6. And the endpoints are connected to form this polygon. So let's go ahead and draw that line. I'm going to pick a different color. Actually, I'm going to go ahead and erase this stuff. And then I'm going to draw my line. So I have 6, 1, 2, 3, 4, 5, 6. and then a negative slope. So there's 1 point, 1 point, 1 point, 1 point. So the line that I'm reflecting over this time is there. So I know that this point B is like one diagonal away, so I'm going to make delta B right here. And then I know A is one diagonal away, so I'm going to make delta A down here. And then I'm going to connect those lines. So the correct answer to this should be a rectangle. So this problem is just getting you guys to review your shapes, make sure you guys remember how to graph and reflect and rotate and do all that stuff for your guys' individual test on Friday. So when you guys come into class, you guys are going to go ahead and start on question 25 and talk about the different types of shapes. We're going to be still working with that transversal and parallel lines. And we'll be going through all these problems all the way up to the reflection of a light problem. And then you guys will have an exit ticket at the end of class. So I will see you guys on Wednesday in class. Have a good night.